Welcome back to another video of Math Today presented by Jude Didelot. It is currently June 6, 2025. Today we'll be solving another sigma notation expression and learn about geometric sequences. Make sure you have watched part 1 of sigma notation because it has important information today. Now, let's get into it. Here we have an expression written in sigma notation with a lower limit of 1 and an upper limit of 5, similar to the last one, but the rule is different. It is now 2 to the n. So let's solve it. Our first value of n is 1, so we have 2 to the first, which is equal to 2. Then we have 2 squared, which is equal to 4, because it's 2 times 2. Then we have 2 to the third, which that's 2 times 2 times 2, which is 8. Then we have 2 to the fourth, which is 16, and we have 2 to the fifth, which is 32. Now, let's add these. 2 plus 8 is 10, and 4 plus 16 is 20. 10 plus 20 is 30, and then we can do 30 plus 32, and we get 62. Our expression, or our answer to this expression, is 62. And this type of pattern is known as a pattern called a geometric sequence. Every time you advance to the next term in the sequence, you multiply by the same number. That number is known as the common ratio. The common ratio is often expressed with the letter r. To calculate the common ratio, you take one of the numbers in the sequence and divide it by the number before that in the sequence. So let's just choose 2 and 4. R would be equal to 4 over 2 because we chose 4 and we're dividing it by the number before in that sequence, which is 2. So 4 over 2 is equal to 2, so our common ratio is 2. Which makes sense because 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, and so on. So do you see where we're getting at with this geometric sequence? There's another formula that we can use when calculating the partial sum of a geometric sequence, like how we got 62 here. The formula S sub n, or the partial sum, is equal to the first term multiplied by the quantity of 1 minus the common ratio raised to the number of terms, which is all divided by 1 minus r. So let's break this down and plug in our numbers. Our first term is 2, as we can see up here, and we must multiply 2 by 1 minus our common ratio raised to the number of terms. Our common ratio is 2, so we're raising 2 to the number of terms that we have, which is 5, as we can see up here. So 2 to the fifth is equal to 2 multiplied by itself 5 times, which is equal to 32. So we can just write 32 here for the quantity of our common ratio, which is 2, raised to the number of terms, which is 5. And this can all be divided by 1 minus our common ratio, which we already addressed, is 2. So let's simplify this down. This is the same thing up here as 2 times 1 minus 32 is negative 31 over 1 minus 2 is negative 1. 2 times negative 31 is negative 62, and negative 62 over negative 1. These negatives cancel out, and we're left with 62 over 1, which is the exact same thing as 62. This is our exact same answer as we had up here when we were solving with our sigma notation expression. This is as far as we will get for today. We have successfully learned how to solve another sigma notation expression, as well as learning about geometric sequences and finding their partial sum with a special formula. Next time, we will learn how to apply the formula for geometric sequences when our upper limit is infinity. Thank you for tuning into Math of the Day. I hope you learned something new. I will see you in the next one, and goodbye.